Okay, so this question said use the graphing utility to graph the function, then answer the following questions. So this is obviously I would type in, I hit the y equals, I type it in, I hit graph, and I get this graph. This window was originally set to negative 10 to 10. This time I didn't have to adjust it, okay? So make sure you know how to adjust your window should your graph go off of your negative 10 to 10. And then my advice is to get the points of that are needed before you even do like domain and range and all that other stuff. It's going to ask you to graph it. So I'm going to go through here and I'm going to find the zeros and the max and the min because that's going to help me graph this. So if I go to second, trace, and I go to 0, there it looks like there's how many zeros? 3, right? Crosses the axis 3 times. So I'm going to go left of the first one, and then right of the first one, and then, oops, that's too far actually, because it caught the second one. So I need to go, zeros, left of the first one. Oops, I keep hitting the wrong thing. Can't see my fingers. 0. Left of the first one. Okay, so question says graph it and then answer the following. So I'm going to type it in my graphing calculator. It looks like this. I hit graph. My window is originally set to negative 10 to 10, and this time it catches everything I need, so I'm going to leave it how it is. I'm going to find the specific point so that I can duplicate the graph on the coordinate plane provided. So I'm going to find the zeros. I go left. We said there's 3 zeros. I'm going to go left of the first one, and then right of the first one means I'm going above. How do you know you're above the x-axis besides just like looking at your graph? William?
On the bottom where it says y.
Good. That y needs to go positive, yes? So even though it's zoomed in and it's hard to see, I already know I've gone up and over the x-axis, right? So this would be to the right of it. So I can hit enter there and then guess, and yes, I'm ready for it to guess, and it's going to take me straight to here. Negative 1.25 and y is 0. So now I've got my first 0 is negative 1.3 is what I'm going to round it to, 1 decimal place. With me so far? Okay, then I'm going to do it again. So second, trace. I'm going to go to my second 0, so 0. This time I want to go to the left of my 0. I'm already there because I've already gone past that 0, right? So this could stay as my left bound and then go right bound as soon as that y gets past the y-axis. Now it's negative. I know I'm right bound. So I can hit enter and then goes straight to that point, negative 0.8. And then I'm going to do it one last time. For the last one. So left bound, right bound, take me to the 0, and I get positive 0.8. So I can already plot those on my coordinate grid. Negative 1.3, let me do a different color. Negative 1.3, 0.8, negative 0.8, and positive 0.8. So those are my zeros. I already have that information. With me so far. Okay, now I got to figure out my max and min so I know how high and how low to go, right? So I'm going back to my second trace menu, and this time I'm going to do, I'll do minimum first, doesn't matter what order you do this in, but I'm going to do minimum. And the minimum appears to be at the bottom there. I have to go left of it, which is here. I have to go right of it, which is here, and then guess, and it takes me to 1.0324 e to the negative 6. What does that e to the negative 6 mean? Good. So it's a scientific notation that's the same thing as saying 1.0324 times 10 to the negative 6, which means I can move my decimal place 6 times to the left. There would be 5 zeros in front of that 1, which means that rounds to what? 0, okay? So that minimum is at 0, negative 4. And then I'm going to do the same thing for the maximum. So second trace, this time I'm going to pick maximum. And I'm going to the left of my max, to the right of my max, hitting yes to guess or enter to guess, and it says maximum is negative 1.07 and 1.1. So negative 1.1, because that's what that rounds to, and 1.1. Good so far. Okay, so now, I'll pause that. Okay, so now I've got this information to add to this. So my max, My max was negative 1.1 and 1.1. So negative 1.1, 1.1 is right about there. And then my min, which was negative or 0, negative 4, is all the way down here. And then I would mimic what's in my graph. So my arrows started down this way and up this way, which means it's going to go up, down, up. Okay? If on your graph tomorrow, because you're going to get a bunch of different versions, I can only make so many look pretty and get them in the graph. If on that graph you get something like negative 20 is a point, feel free to draw it down and then just like label it so that it doesn't have to be perfect, but at least I know what your graph looked like. Okay, you don't need to like do little extra 10 tick marks. You could bring it all the way down and put a point and say this would have been negative 20. Okay, same thing if it was up and off the graph. So now based on this graph, what would you tell me the domain is? Negative infinity to infinity. I'm hoping that you're sleepy and that's not something you don't know. Okay, my arrows are pointing left and right, which means negative infinity to positive infinity. Okay, how about my range? Negative infinity to positive infinity. They are pointing down and up. Determine the intervals on which the function is increasing, decreasing, or constant. So if I look at it closely, here and here are where it's increasing. So this goes in interval notation. Increasing would be from negative infinity up to this, and it's the x value, right? Which was negative 1.1. So this point here was negative 1.1, 1.1. And that point there we already know is 0 and negative 4. Then it increases again at the end from 0 to positive infinity. Again, always using the x points and always using interval notation. And then it's decreasing from here to here. So the x coordinates there are negative 1.1 to 0. And no point is this flat, which would make it constant. Still with me? Yeah? Okay, the last question that we haven't answered is the function even, odd, or neither? So how do I know if it's even? Okay, so two ways. First is from the equation, I can take a negative x to the fifth minus 2, negative x to the third, plus 6, negative x to the second, minus 4. This would equal y. And I can see if it's going to go back. So a negative x to the fifth means this is going to be negative. A negative x to the third means a negative times a negative 2, which is positive. A negative x squared, which means it's positive. And negative 4. So it doesn't match the original. And then I want to compare all the signs. This is negative, that's positive, that's one change. This is positive, that's negative, that's 2 changes. But this is positive and that's positive, which means they all did not change. So this function is not even. I can also look at my graph and see if I can fold it along which axis. The y-axis. So if it's even, it gets folded like a hot dog, right? Left to right, overlaps. If it works, then it's even. This one doesn't, okay? And then to test for odd, not only do I change the x, which would change this whole side, but I'd also change the y. So I'd get negative y equals negative x to the fifth plus 2x to the third plus 6x squared minus 4. Again, not the same as my original. Most of them change, but that 6x squared doesn't change, nor does the negative 4, which means it's not odd either, which means this is a neither situation. If I was to look at my graph to see if it's symmetric to the origin, I would fold it top down and then left to right and see if it overlaps. Or along the y equals x or y equals negative x line. Like if it overlaps folding along those either of those diagonals, then it would be symmetric to the origin, which it's not. Questions? Can you do this by yourself tomorrow? Yes. Okay, if not, you got some work to do tonight.